Hello students! So this video here, this little lesson is still on transformations, and I didn't want to move on too quickly because again with transformations we want to make sure that you get a good gist of how to do everything. Guys, this video is about transformations with function notation, and we're putting it all together. Okay, so guys, we've done the different types of transformations, and when we looked at those different types of transformations, we did them separately. So we've done translations, and we've talked about how to do translations. We've done reflections, and we talked about how to do that. We've done your dilations, and we talked about how to do that. But guys, here we're going to put it all together. So with this one here, we're going to see a form where it not only includes just one transformation, but we're going to see it where it definitely includes more than one transformation. Okay, and so and that's why we're still talking about transformations, because you haven't. Well, I'm talking to my students who are enrolled in my classes. You haven't seen all the types of these transformations yet, as far as when they've all been put together. All right, so let's go ahead on and get started. And we're going to remind you of again what we talked about very briefly. We're going to remind you of some of those different forms and how they look when they are in that function notation. And again, guys, I made those charts, some of those charts for you in the previous videos. Okay, so guys, this chart here is one for translations, and actually this was actually the only one, the only chart that I had not already made in a previous video for you. But anyway, we did talk about translations, and we looked at different examples, even with these six parent functions. But anyway, in this chart here, it shows you again how each of these types of parent functions is going to look for these types of translations. Again, it shows you how each of these types of parent functions is going to look after, if it's written with a translation of going up by k units. And again, we know that k represents some number that's being added or subtracted. And again, yeah. Again, guys, you can see here that again it's got these different types of equations, and the way that they're going to look if you are doing these particular translations. Oh, why didn't y'all tell me that I put K for the translations for the left and the right? That's all right. That's okay. That looks better. Okay. Again, guys, we've gone through this before. Again, the chart might be new, but again, we've talked about these translations before. So again, okay. So guys, this chart here was one that we had made specifically for reflections. That was in one of the previous videos, and again, guys, with these, you can see exactly how each of the equations, or how each specific parent function would look with those types of reflections. The reflection about the x-axis, with the reflection over the y-axis, with the reflection over both of the axes. And again, we did a whole lesson, a whole video, and a whole lesson on that with practice and everything as well. But again, just reminding you that we have done this separately. Okay, so this chart here was another thing that we had talked about with your dilations, and this chart in particular was one that we had in a previous video that talks about the vertical dilations of when you're going to have a vertical stretch or a vertical shrink, and what those scale factors are going to be, and how each equation looks, or when you are doing a vertical stretch and a vertical shrink. So again, we talked about that. We had a whole lesson on dilations and reflections, and where we showed you examples, and we showed you how to do them on deltamath.com and everything. You know, my students who are enrolled in my classes. And this chart here was the last one, where it was on horizontal dilations. And again, guys, just like with the other charts, there it's got all of the types of parent functions. But again, guys, even though we've talked about each of these types of transformations separately, guys, now is where we want to put them all together. Okay, so again, in all of these charts that I've shown you, each equation only has one transformation. But again, we're now about to get to a place where we're looking at functions where there's more than one transformation occurring, and equations where there are more than one transformation that is occurring. So guys, we're going to look at a general form for what that might look like. And again, guys, this general form may look a little bit abstract when you see it, but again, just bear in mind that it represents all of these different changes that we talked about put together, and it represents what the function notation could look like if it literally involved all of these types of transformations that we've talked about here, besides rotations, because we haven't done anything specifically tailored to rotations as far as with functions. But anyway, guys, here we go. All right, so guys, here it is. This is sort of like a general type of form for this for function notation that this form here, it has pretty much every type of transformation involved here, and not that we're going to be looking at equations that are involving every type of transformation. But again, guys, you can see here that the parts f of x, where f of x represents the parent function, and you can see the parts that have been changed. So those other parts that are not the f of x, those parts represent transformations that are happening there. So some of the transformations are changes that are happening inside of the function, and we've talked about this before too, but again, I want to remind you. So again, some of the changes are changes that are happening inside of the function, and those inside changes, ooh, that's sloppy, it's okay. Those inside changes that are happening inside of the function are those horizontal transformations. horizontal transformations. So again, that's not how you spell horizontal, but it's all right. All right, and then again, guys, the outside changes that are happening, the parts outside that are not the F, okay, of the parts that are outside. Those represent your vertical changes, and again, we've talked about this already, but again, I want to remind you of that, and of how important it is for you to remember and for you to be able to recognize when you've got changes happening inside your function, okay, and when you have changes happening outside of your function. You need to be able to recognize the difference between those types of changes, not only when you're looking at like a general type of function notation like what we're looking at here, but also when we're looking at specific parent functions and those equations. We need to be able to recognize it with them as well. Okay, so these ones that are happening outside are vertical types of changes. Reflections, it could be reflections, dilations, or translations, again. Okay, so guys, here, and don't get too distracted by the different colors, but again, guys, here we've got that same general form, where again we've got where we've got all of the different types of transformations that we've discussed and that we've talked about. We've got all those different types of transformations included here. And again, guys, I've got it kind of broken down and sort of color coordinated as far as these separate transformations that are in here. Again, guys, and up here at the top, with the stuff that's in the green, pink, or maybe we call that magenta, and this goldish type of color here. So the stuff, all that stuff at the top that you see, the green, the pink, and the gold, those three transformations are all horizontal. Why are those three all horizontal? Because those are the three changes that are happening inside of the function. They're happening inside of the function. The plus or minus part that's inside the function, you see where my mouse pointer is? The b that's inside the function being multiplied times that x, and then that plus or minus h inside the function there. So again, guys, it is, and we've talked about this before, but again, guys, it's a horizontal reflection over the y-axis only if there's a negative number that's multiplied inside of the function. So again, that part there inside the function, only if there's a negative number multiplied inside the function. That's the only time there will be a horizontal reflection. Again, guys, the horizontal dilation, there will only be a horizontal dilation, which is a stretching or shrinking of the x values, only if the number multiplied inside of the function has an absolute value that's not equal to 1. So again, if that number that's multiplied inside of the function if the absolute value of that number is not 1. And again, guys, the scale factor for the horizontal dilation is going to be 1 over b. It's going to be 1 over b. In other words, guys, it's going to be the reciprocal of b. So again, guys, that scale factor is going to be 1 over b. And I know I didn't have it written like that because, you know, that's typed, and for this thing I couldn't type that. But anyway, it's 1 over b, or in other words, the reciprocal of b. And we had talked about what reciprocals are in one of the videos. We talked about all of this already separately. Now we're just putting it together. And again, guys, remember that whatever that scale factor is, that you take that scale factor and you multiply it times the x values for the horizontal dilation. You take the scale factor and you multiply it times the x values. And again, guys, that's for the horizontal dilation. And again, folks, for the horizontal translation, it is only a horizontal translation, which is a sliding to the left or to the right, only if a number is added or subtracted inside of the function. So again, guys, it's only a horizontal translation if you're adding or subtracting a number inside of the function. And remember, guys, it is going to be to the left if you're adding some number, and it's going to be to the right if you're subtracting some number inside of the function. Okay? Alright, so those are your horizontal changes that happen inside the function. And again, we've talked about this already, guys. At the bottom here, with the red, the dark blue, and this light blue, we've got the vertical changes. And again, those vertical changes, they happen based on changes that happen outside of the function. So again, the plus or minus that's on the outside, the number that's being multiplied on the outside, and whether or not there's something added or subtracted on the outside. Those are all vertical changes. So again, guys, there's only a vertical reflection if there's a negative number that's being multiplied on the outside. So only if there's a negative number multiplied on the outside is there a vertical reflection. And again, a vertical reflection is going to be a reflection over the x-axis. Guys, there's only a vertical dilation, which changes the y values. There's only a vertical dilation if the number being multiplied on the outside of the function has an absolute value that is not equal to 1. And again, guys, for a vertical dilation, the scale factor is going to be a. And so again, for vertical translation, guys, remember there's only a vertical translation, which is a sliding up or down. There's only going to be a vertical translation if there's a number that's being added or subtracted on the outside of the function. And remember, guys, that again, for vertical translation, it's and for all of your vertical transformations, it's going to sort of be the way that you would expect it to be. So for vertical translations, if we are adding some number on the outside, it's going to cause your function to be shifted or slided up. And if it is subtracting some number on the outside, okay, yeah, we can do better than that. If it's subtracting some number on the outside, yeah, we can do better than that too. It's okay. All right, then it will be a slide or shift down. And guys, again, we've talked about all this together. We've talked about all of these transformations separately, but again, here we're putting them together, where you may see more than one in the same equation. You may see more than one transformation in the same equation. That's why you see all of these together in this same function notation. Okay, because that's what this lesson is about. Okay, guys, just in case I had a little bit, I did just talk about this chart, but just in case I had a little bit of a glitch with the video, this chart here kind of shows each specific each specific parent function and how it could look with this general form of transformations, where it includes more than one type of transformation in there. So you can see it with each type of parent function here. And I'll just let that sit here for maybe about 10 more seconds. Again, just in case I had a little glitch with it, and just in case it didn't record it the first time that I just talked about this. But again, I'm confident that it is recording right now. So again, this chart talks about or shows you each specific parent function and what it could look like. And again, guys, that's that. So next up, guys, we're gonna look at a few examples, specific examples with these absolute value, or sorry, with these parent functions, and we'll go from there. And after we look at these examples, I'll show you specifically, or make sure that you know how to do those Delta math assignments that are a part of today's lesson. Okay, so guys, this here is an example, and for each one of these examples, I'll give you an equation, and this equation is the result after some transformations have happened, and I want you to be able to look at an equation like this and identify what the parent function is. This will help you when you're doing your Delta math practice assignments too. Be able to look at that equation, identify the parent function, part A, be able to write out the function notation, including the changes that are happening to that parent function, part B, right? And be able to state the specific transformations that have occurred. So let's go ahead on and do this, all right? And we got to kind of hurry up here because it's kind of late, and we still need to be able to upload these videos. All right, so the parent function here, excuse me if it seems like I'm rushing through this. All right, the parent function here is and we'll just use f of x, but the parent function is the quadratic parent function, guys. All right, and so the changes that are happening to this, there are actually no changes happening inside of the function. So the only thing that's happening inside the function is still just x. But on the outside of the function, guys, is being multiplied by 1/2. So the outside of the function is being multiplied by 1/2. And again, on the outside also, we're subtracting 5. So this is part B here. All right, so that's the function notation. We got the parent function, the function notation, and then, guys, looking at exactly what transformations are happening there. State the specific transformation. So if we're multiplying by 1/2 on the outside, that's going to be a vertical dilation, and specifically, guys, is going to be, this part here is going to be a vertical shrink. It's a vertical shrink, and the scale factor is going to be 1/2. And again, guys, what that means, if it has a scale factor of 1/2, is that you'll take your you'll take your x values, you'll take your y values and multiply them times that scale value. If this is the vertical dilation with a scale factor of 1/2, right? All right, so that part is a vertical shrink with a scale factor of 1/2. This part here is a translation, and it's going to be down 5. Again, that's that. This example. Up next. Okay, Okay, guys, this next example here is, and so we got the same parts. Excuse me if it seems a little rushed, but we're running a little short on time here. All right, the parent function here is the exponential. Is your exponential function? Yeah, I don't know why I just wrote the word parent, but it's all good. And with a base of 2, and that's that function with where you have 2 raised to the power of x. Guys, when we look at the changes that are happening here, so one change is happening because there's a negative on the outside of this function. There's a negative there in front on the outside of this function, and we know that it's on the outside of the function because it's not a part of the exponent. And then there's a change happening inside of the function, inside of this function with the x as part of the exponent. So along with the x as part of the exponent, they've got a number being multiplied on the inside. So again, guys, with this one, they don't have to put the parentheses when they do the equation. It could be y equals -2 raised to the power of 8x without parentheses. All right. So again, these specific transformations here. This is a vertical reflection, and specifically, okay, yeah, that's sloppy, but it's gonna have to work for now. It's a reflection over the x-axis. And were you multiplying this 8? Yeah, that's a sloppy arrow, but with the time we got, I ain't got time to correct that right now. It's going to have to work. I lied. I'm going to correct it. All right. With that being multiplied by 8 on the inside, it's a horizontal dilation. But again, which dilation? It's a horizontal shrink. It's a horizontal shrink by a factor of 1/8, because again, we do the scale factor. For the scale factor, we had to take the reciprocal of that number. So it's a horizontal shrink. Scale factor is 1/8. Yeah, that's not scale. There we go. Now it's scale factor 1/8. All right, so again, what that means is if your scale factor is 1/8 for this horizontal shrink, that means you'll take your x values. If you had a graph and you had certain points there, you'll take the x values and you'll multiply the x values by 1/8. All right, next example is y equals the cube root of -x plus 9. Yeah, that's a 9. Plus 3, no, -2. There we go. All right, and so again here the parent function is the cube root. Wow, really? Is the cube root. And again, that is the function f of x equals the cube root of, with the little small 3 on the outside, the cube root of x as the parent function. All right, and then the changes that are happening here. So there's definitely some changes happening on the inside because there are changes happening up under that radical. And so on the outside, we've got it being subtracting 2 on the inside with the x up under the radical inside the function. We've got a negative being multiplied there, and we've got a 9 being added. Okay, so this negative here is a horizontal reflection, which is a reflection over the y-axis. Okay, this plus 9 on the inside is either left or right, but specifically is going to be to the left 9. Left 9 units. And then this one here is going to be down 2 units. Specific transformations that are happening here. Alright, next. Example 4. Y equals -3 times the absolute value of x minus 4. Okay. Alright, so here the parent function is clearly an absolute value one. Yeah. And again, that is the function f of x equals the absolute value of x as the parent function. Okay, I can't. Yeah, there we go. Couldn't leave it like that. I could, but I couldn't. All right. So the changes that are happening to that parent function, there's some changes happening inside the function. So inside the function, you don't only have x inside of there, but you also have -4 happening inside of the function. On the outside of the function, you've got a negative, and it's also being multiplied by 3. So you got it being multiplied by 3, and it's negative on the outside. So the negative here, that's going to be a reflection, a vertical reflection, and specifically it's going to be a reflection over the x-axis. This 3 being multiplied on the outside is going to be a vertical dilation, and specifically is going to be a vertical stretch with a scale factor of 3. Okay, yeah, that's just... All right, that's this one. Next, example 5. Y equals -1/2 x minus 8 cubed plus 7. All right, so for this one, your parent function is a cubic. Is your cubic function, and again that is f of x equals x cubed. That's that parent function there. All right, and so the changes, there are changes happening inside of the function and outside of the function here. We can see the outside of the function, which is going to be outside of the part that's being cubed, outside of the parentheses. You see the plus 7, and then inside of this function, along with the x, inside of the function, we've got a negative that's being multiplied, and it's a negative number, and it's multiplied by 1/2, and you've also got an 8 that's being subtracted. So that's 1, 2, 3, 4 different transformations happening here. The negative on the inside is a horizontal reflection, and specifically that's a reflection over the y-axis. Okay, this multiplying it by 1/2 on the inside is a horizontal dilation, and specifically it's going to be a horizontal stretch, because again those horizontal changes sort of do the opposite of what you would expect it to do. Multiplying it by 1/2, you wouldn't expect multiplying it by 1/2 to stretch, but again, as a horizontal transformation, it is going to stretch, and it has a scale factor here. The reciprocal of 1/2 is 2, so the scale factor here is 2, and this -8 on the inside Again, that's going to be shifting it either left or right, and specifically, this is going to shift it to the right. Again, folks, right 8. Again, folks, these inside transformations sort of do the opposite of what you would expect if you know what it's supposed to do. And again, this adding a number on the outside here, that could be up or down, but again, specifically because we're adding and not subtracting, because we're adding, this is going to be up 7 units. All right, that's this example. Number 6. I hope and pray that this video is recording right now. Yes, it is still recording. Awesome. Okay, back to this. Example 6. All right, we've got y equals negative square root. Okay, yeah, that square root look all jacked up. That's better. Square root of 2/5 x minus 11. Oops. Okay. Minus 11. All right, so for this one, clearly the parent function is a square root. Parent function. And again, that is f of x equals the square root of x, the parent function for it. Looks like that. And there are changes happening outside of the function and inside of the function for this. Guys, inside of the function, we know that's the part that's happening up under that radical with the x. And the only thing that's happening inside of the function is the fact that there's a number being multiplied. That number is 2/5 that's being multiplied times x on the inside. On the outside of the function, you've got this, it's negative, and technically the number that's multiplied on the outside here is -1. It's times -1, but again, it's a negative there. And then you're also subtracting 11 on the outside of this function. So again, there are 3 transformations here. This negative on the outside is a reflection, a vertical reflection, and it's a reflection over the x-axis. This multiplying it times 2/5 on the inside is a horizontal dilation. Specifically, guys, this would be a horizontal stretch. Because this number that we're multiplying it by on the inside is smaller than 1. Okay, and even though multiplying it times a number that's smaller than 1, you would expect it to get smaller, but because this is a horizontal transformation, it does the opposite of what we would expect. And so again, because this number that we're multiplying it by is smaller than 1, then this is going to be a horizontal stretch. Okay, let's try again. Yeah. Horizontal stretch. Yeah, okay. And here the scale factor for horizontal dilation, you got to do the reciprocal to get the scale factor. The scale factor here is 5/2, or in other words, 2/5. Same thing. You can leave it as a fraction, you can write it as a decimal, it doesn't matter. 2/5, 5/2, 2.5 or 5/2. And the last transformation happening here is because of this subtracting 11 on the outside, and that is down, wow, really? That is down 11. Down 11 units. All right, that's number 6. Next, number 7. All right, so number 7 is y equals 4 times 2 raised to the x plus 1 Yeah, okay. Okay, yeah, that's better. Plus 6. Okay. All right, so guys, again, this parent function is an exponential that has a base of 2. Exponential parent function with a base of 2. And again, that is f of x equals 2 raised to the power of x. And again, guys, sometimes, and I'm going to erase this part with the parentheses. Sometimes you'll see it with the parentheses. Other times you'll see it without the parentheses. But again, guys, you'll know what changes are happening inside. Because, well, for exponential, you'll know what changes are happening inside, because, guys, that part will be, the inside part will be a part of your exponent. It will literally be a part of your exponent with the x, whether you see parentheses or not. All right, so we have changes here happening inside the function and outside of this function. The changes that's happening inside the function with the x is the fact that it's adding 1 as part of the exponent, again with the x inside the function. On the outside of the function, it's multiplied by 4. And again, guys, this could either be written with the multiplication dot or without it. But again, that's 4 times. So it's being multiplied by 4 on the outside. And also, guys, it's adding 6 on the outside. Again, guys, there are 3 transformations here. This 4 on the outside is a vertical dilation, and it is specifically a vertical stretch. And guys, the scale factor here, wow, that's not stretch. And the scale factor here is 4 for this vertical stretch. Scale factor is 4. And here we've got this adding 1 on the inside. That is a horizontal translation, either left or right. It's shifting left or right, and this specifically will be shifting to the left by 1. It's going to be to the left 1. Yeah, I don't know why I wrote 1 that way. I do know, but I don't know why. All right. Again, this one here, where we're adding 6 on the outside, this is going to be a vertical translation, and specifically, it's going to be a shift down 6 units. Okay, guys, those are all the examples that I'm going to show. Next, guys, and really briefly, because it's getting about that time. Really quick. Next, I'm going to show you very briefly and make sure you know how to do the Delta Math assignments. This I'm talking to my students enrolled in my classes at our school. Okay, guys, this here is one of the types of problem sets on your Delta Math. And it's asking, or really, they want you to kind of sort of play around with this function notation. And see here it says discovery. They kind of want you to play around with this function notation. Okay, good. We're recording. Wanted to make sure. And so for this, again, you can play around with it to make the black function match the dotted function. So again, you can change the sign on the outside. Again, that would be a vertical reflection across the x-axis. You can play around with it to see what that would look like. If you change the sign on the outside, right? Vertical reflection across the x-axis. You can play around with this part here. It would be a horizontal reflection over the y-axis, right? So again, you can play around with that. You can shift it to the left or to the right. And kind of play around with that to see how that would look. Okay, here, guys, the way I would suggest, like if you do get one like this, I would especially if you see like if you see 1 point. Well, I would play around with the reflection parts first if you need to, and then I would kind of focus in. Do you guys kind of see 1 point? Like I can see an x-axis here. On the x-axis, I see a point that x-intercept is 2, and so if we were going to go from that x-intercept of 2 to and what I'm looking at, it looks like it is going left 2, so I'm going to change this to plus 2, because again it looks like it's going left 2. Okay, so let's see what that does. That looks all right so far, and it looks like it has gone down how much? Down 6. Let's check that out. Down 6. And you can play around with it until, guys, it literally will not let you submit it until you get it so that it matches it. But you can play around with it and play around with that function notation until you get it right. Okay, so you have no choice but to get this correct unless you give up on it. Okay, and this is all right. So that's one type of problem set on Delta Math. I gotta hurry up. Okay, so guys, this is the other type of problem set. Let's make sure we're recording. Okay, good. We got time to do that over. This is another type of the problem sets on Delta Math here. And so, guys, for these, you've had other Delta Math assignments like this, where you actually have to transform the functions. But before, guys, you only had to do one specific type of transformation. In this one, there's more than one transformation happening. So, guys, if you look at this, this is a cube root function, and actually, guys, there's no changes happening inside of the function, but there is a change. There's 2 changes happening outside of the function. It's multiplied by 4 on the outside, and so, guys, if it's multiplied by 4 on the outside, then what we want to do is, and give me 1 second real quick. Just make sure we're recorded. We're good. All right. So guys, when you're doing the Delta Math assignment where you have to actually transform the equations, what you want to make sure you do is you want to make sure that you do the transformations in a specific order. If they've got different types of transformations, guys, you always want to do, like, if they do have reflections, you want to do reflections first. When you're doing it on the Delta Math assignment, I'm letting you know, if it has reflections, you need to handle the reflection part first. And guys, you've already done Delta Math practice problems for each type of these transformations. So that part shouldn't be difficult. But again, you'll handle the reflections first, if there are any, and next, guys, you'll handle the dilations, if there are any. You'll handle that next. And again, the last thing that you'll want to handle, if there are any, is the translations. Okay? So listen carefully about that, all right? All right, so here, there are no reflections. That would be the first thing, but there is a vertical dilation of 4. So since the scale factor here is 4, remember, guys, we've done this type of problem before. I don't have a whole lot of time here. I've just dilated that by moving this point, and I've multiplied the y value here times 4. The y value was 1, and now it's 4. And I've moved it, I've clicked, drag, and held that, and I've done that dilation. Okay, now it's been stretched by a factor of 4, scale factor of 4. And guys, the last transformation here that we need to do on this problem is a shift down. It's a translation, a vertical translation, and this is going to be a shift down 1 unit. So we're going to move this green dot to do a translation down 1 unit. Okay, and that is it, guys. That is it. Yes, I want to submit just to show you, Mr. Starkey, know what he's talking about. That's it. Okay. All right, I hope that this video has been helpful. That's all, folks. That's it. Hope it's helped you. Good night. Bye-bye. Still got work to do.